Hi, here we have another question from Iranian Mathematical Olympiad year 1997, round number 1. This is an algebra question and the topic is about polynomials. So we have a polynomial px which is equal to x power n plus an minus 1 x power n minus 1 plus till a0. ai are all integers and we know that p1 is equal to p2 is equal to 0. We have to prove that at least one of the coefficients is less than or equal to minus 2. First round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions for 3 hours. So you have on average 6 minutes per question. If you answer correct, you get plus 3 points. And if you answer wrong, you get minus 1 point. Therefore, you have to select your answers very carefully. This question was among moderate difficulty level. So maybe you can spend 10 minutes try to solve this exercise and then come back and see the solution. So these are the options that we have. A, the constant term a0 is less than or equal to 2. B, the difference between the number of positive coefficients and the number of negative coefficients is at most 1. C, the sum of the coefficients with odd powers is minus the sum of the coefficients with even powers. D, at least one coefficient is less than or equal to minus 2. And E, none of the above statements is true for all such polynomials px. Alright, so let us see the solution. We have this polynomial that is given and these are the properties that we have. Obviously, we know that p1 is equal to 0. Therefore, if I put instead of x equal to 1, what I obtain is that 1 plus an minus 1 plus an minus 2 till a0 is equal to 0. Obviously, what I obtain is that sum of the ai, if I is an odd number, plus sum of aj, if j is an even number, is equal to minus 1, because this one plus 1 is equal to 0, therefore this will be minus 1. Therefore, the sum of the coefficients with odd power is not equal to minus the sum of the coefficients with even power. And with this, we can actually eliminate option C. Normally, if we also consider all coefficients, even this coefficients of xn, then that statement will be correct. But here we are talking only about ai's, and therefore this statement is not correct. So this option can be easily eliminated. Obviously, this is not the way to prove an exercise, but sometimes we have to eliminate options if the question is a multiple choice question. All right, let's continue with our thinking. When we know that p1 and p2 is equal to 0, obviously we can write px as x minus 1 times x minus 2 times another polynomial qx, because these are the roots, so we can write px in this format. And we can expand this, so this becomes x2 minus 3x plus 2 times qx. And of course, we don't know what qx is. It can be anything. Therefore, sometimes we have to guess. For example, I can put qx, the very simple polynomial, x plus 1, and see what we obtain. If I put x plus 1, then yeah, you can multiply. This becomes x3. This is x2 minus 3x2. So basically, eventually we get to this one, x3 minus 2x2 minus x plus 2. But if we look at the polynomial that we obtained here, basically we cannot eliminate any of the answers with this polynomial. So it's not going to help us. But we can also try other polynomials here. For example, instead of x plus 1, I can try x plus 100. And why I tried this? Because when we have, this is x3, this one will be 100x2, and this one will be minus 3x2. Therefore, 100x2 minus 3x2 will create a positive number, 97x2. So that's why I increase this value, because here when we have 1, here we have x2 minus 3x2, so it creates minus number, but here we can create a plus coefficients for x2. So if we expand this one, what we obtain is that, okay, we get x3 plus 97x2 minus 298x plus 200. What can we obtain? One thing that is clear here is the constant a0 is 200, which is obviously much larger than 2. In that case, we can also eliminate option A, which is this one. But what about the other options? Yeah, we have to see. Maybe we should try other polynomials instead of qx. So in this case, I tried another polynomial, x2 plus 4x plus 100. Why I tried this? Because one of the options, it says that the difference between the number of positive coefficients and the number of negative coefficients is at most 1. So I was trying to create a polynomial that when you multiply together, we create many coefficients to be positive and only a few to be negative, therefore violating this condition that is given here. That is why I selected this polynomial. For example, you can see here we create x4. Okay, x4 is the first term. That's fine. This one we create 4x3, and here we create minus 3x3. So 4x3 minus 3x3, it gives us x3 plus x3. So that's why I put the number 4 here, because I wanted to, when we add these two together, it becomes a positive number. And then if you basically multiply these two polynomial together, you get to something like this: x4 plus x3 plus 90x2 minus 292x plus 200. And in this case, you observe that we have 3 positive coefficients and 1 negative coefficient. Therefore, that option which states the difference between positive coefficients and negative coefficients is at most 1 can be easily violated. So the numbers that are selected here are intentionally selected so that we create most of them positive and only a few of them negative. And you can basically exercise and try to guess what numbers you can use. This is an example that I found. In that case, easily we can eliminate option B. And of course, in this case, we have left with two other options. At least one coefficient is less than or equal to minus 2. So now we are going to prove that this option is really correct. Obviously, I could start the answer by proving that this option is correct, and then we would finish the exercise. But sometimes you have to eliminate the options that are not correct and give you more confidence. Then you can really prove that this option is correct. All right, so this is the polynomial that is given to us. Let us assume that all ai are equal or larger than minus 1. I'm going to show you that this is a contradiction, and therefore at least one ai should be equal or less than minus 2. So if ai is equal or larger than minus 1, we are going to evaluate px. So we know that px will be larger or equal to xn. Instead of ai, I'm going to put minus 1 here. Then we know that px will be larger than this. We assume that x is a positive number here. And then we are going to evaluate px at point 2. So p2 will be equal or larger than 2 power n minus 2 power n minus 1 till minus 1. All right. But we know that this geometrical series 1 plus 2 plus 2 power 2 till 2 power n minus 1 is equal to 2 power n minus 1. Therefore, p2 has to be equal or larger than this, and this is equal to 2 power n minus 2 power n plus 1. Therefore, p2 has to be larger or equal than 1, and obviously this is a contradiction because we know p2 is equal to 0. Therefore, we conclude that there must be an I such that ai is less or equal than minus 2. All right, so in this case, we have shown that this option D is correct, and therefore option E will also be incorrect. All right, let's see what we have learned throughout this video. Use the information given to obtain new properties for coefficients of the polynomial. The second technique that you have to try is to try to make counterexample and eliminate some of the options if the exam is a multiple choice question. The other one is a polynomial px with a given root at x1 and x2 can be written at px is equal to x minus x1 times x minus x2 times another polynomial qx. And when you write it like this, sometimes it reveals new information about the polynomial px, and you can use it to solve the exercise. All right, so this is the end of the video. I hope you learned something new. See you next time. Bye.